Amrita. Hello,
Hello.
Amrita.
Yeah.
So let us continue from the last one, Amrita.
Okay.
We did up to question number 3, IGCSE paper, May, June 2020, 12th one. Okay, so let us continue. Look at this question, Amrita. Here it says, how many different 5-digit number can be formed using all of the 6 digits given? One condition in the original question is, it cannot be repeated.
Right.
So as we need 5-digit numbers, there are 2 ways to do it. One, you apply the formula, that is out of 6 we need to consider 5, so it is 6p5, which is 6 factorial divided by 6 minus 5 factorial, right, Amrita?
Right.
What will that give you? It's just 6 factorial, which is 720, correct? This is one way of interpreting the question. The other way of interpreting the question is, let's say there are 5 slots to be filled, correct? Because it's a 5-digit number that we need.
Right.
Suppose there is no condition. Let us say I go to the second position. All the digits are available. How many ways can I fill this position? Any 6 number can go there, correct? Let us say I fill this one after this 5 ways, 4 ways, 3 ways, and 2 ways. This many ways you can do it, and when you multiply them with each other, and that value will be again 720. 2 different ways to interpret the same thing. Now let's go to question number 2. How many different numbers are there such that it is not divisible by 5? First of all, it's easy to consider a number that is divisible by 5. What should be the condition?
The last digit, I think one's digit.
The unit digit should be either 0 or 5, correct?
Right.
So here, so I start with this 5 positions to be filled. Let's consider filling the last position, Amrita. So there is only 5 that matters here, correct? So how many ways can I fill that position?
So only way. Yeah.
Isn't that correct? Now, there is no other condition given. So let us say I fill the adjacent position. How many digits are available for us to fill that position?
5.
Any of the remaining 5, correct? So this can be filled in 5 ways, 4 ways, 3 ways, 2 ways. So you essentially multiply all of these things with each other. Now this is 120. By the way, let's actually name what is that we did. Numbers divisible by 5.
Right.
This many choices are there for that. Is that clear, Amrita?
Yeah.
However, the question is numbers which are not divisible by 5, Amrita.
Right.
So how do we do this? Let us consider the total possibilities are given to be 720. This is number of ways you can have a number divisible by 5. So numbers not divisible by 5 will be
7 minus 120.
minus 120. It is 600.
Right.
Let's continue to the next question.
Okay.
How many of these numbers found in part 1? Oh, not question number 2, question number 1. That is out of the 720. How many of them are even and greater than 30,000?
Right.
There are 2 points here. One is it has to be greater than 30,000, and it must end in an even digit. Correct, Amrita?
Yes.
So here there is a little bit of kind of a complex level. That is, depending on what is the final position, you will have less choices for the first position. Let me explain that to you. So we will break it down into 2 different possibilities. Numbers ending in 8. That's one way of forming even numbers, correct? When you consider 1, 2, 3, 5, 7, and 8. The other possibility is numbers ending in 2.
Right. Yeah.
So let's consider numbers ending in 8, Amrita. So when you fill up the last position, how many ways can you fill it? Only one way, because it has to be that 8. Correct?
Right.
Now, because it is a 5-digit number and because it must be greater than 30,000. Look at how many ways can I fill the first position. It has to be either, let me use the same, either 3 or 5 or 7, correct? So there are three ways we can fill this position, Amrita. Now there is no other condition. How many numbers are remaining? 8 is already used. One of the 3, 5, 7 is already used. How many remaining numbers are there now?
4.
4 of them. So any 4 can go here, 3 can go here, and 2 can go here. So when you multiply all of those things, that's going to give you, let's multiply, this is going to be 12, and this is going to be 6, that's going to be 72. So what's the meaning of the 72? There are 72 even numbers with an 8 at the unit position, and these are greater than 30,000. Let's consider numbers which ends in 2 and still greater than 30,000. So like how we did earlier, Amrita, we start with all of these 5 positions, and first let's fill the unit position. Only 2 must go here. So this can be done in one way. However, now when we go check how many ways can we fill the unit position such that it's going to be greater than 30,000, either 3 can be there, or 5 can be there, or 7 or 8 can be there. There are 4 choices here for the unit digit. Now we can use 8 also. Now we have filled the first position with one of the 6 digits. 4 ways we fill this left side position with one of the remaining 5. So there are 4, 3, 2 ways we can fill the remaining numbers. Is that clear, Amrita?
Yes.
This time you need to multiply all of those things, and that's going to give us 96. Correct. So either this or this, so all put together it is going to give you 168.
Okay.
Now let's continue to the next question. Look at this, Martha. They're expecting us to form sort of an algebraic equation to solve it. Okay, look at this. What do you understand? This question is essentially saying n items with 3 taken at a time versus n items with 2 taken at a time. So NC3 versus NC2 is what they are saying. So which one is greater? Left side one is greater. 6 times the right side one is the left side one. The question. Is that clear?
Yes.
Now, what is the formula for NC3? It is n factorial divided by n minus 3 factorial multiplied by 3 factorial. And the other one is 6 multiplied by n factorial divided by n minus 2 factorial multiplied by 2 factorial. Is that okay, Amrita? Okay, now let us simplify this. Few of those things will obviously go. N factorial and n factorial can go. By the way, for your information, Amrita, n factorial is never 0. Even 0 factorial is 1. You can confidently eliminate that. Now, what we have now is, let's kind of cross multiply and get whatever is remaining on everything onto one side and other side. So it is n minus 2 factorial multiplied by 2 factorial. Oh, there's one more thing I can do. Sorry, I didn't see this one. This can go, and what will remain? There's 3 remaining. Okay, so now let us combine all of those things. You have on the left side n minus 2 factorial. On the right side you have 3 multiplied by 3 factorial multiplied by n minus 3 factorial. What I want you to keep it in mind is the following. Say 4 factorial is 4, 3, 2, 1. In a way, this is 3 factorial, isn't that correct? So it is 4 multiplied by 3 factorial. Using the same idea, we can actually deal with this n minus 3 and n minus 2 factorials. So n minus 2 is essentially n minus 3 factorial multiplied by n minus 2. Same as what we have done there with the 4. On the right side, we have 3 into 3 factorial multiplied by 3n minus 3 factorial, right? Now, n minus 3 factorials are same. We can cancel them out again here.
Yeah.
Okay?
Yeah.
So now 3 factorial 6 multiplied by 3 is 18. So n minus 2 is 18 and therefore n is equal to 20. And that is the answer to the question.
Right. Yeah.
Let's continue, Amrita. Have a look at the 5th question. What does it say? Question says, first of all, calculate what is the range. Here, one mistake students make is given that x is greater than 0, Amrita. So, even though parabola comes to your mind, it is not entirely the parabola because
Right. It is not.
exactly. So, ideally, maybe I can draw a slightly better graph here. 1 second. My handwriting had been pretty messy, so let me use it. Okay, so ideally what we would be expecting is there is going to be a parabola that goes something like this, right? However, according to the question, because x is greater than 0, Amrita, only thing that matters is this green portion.
Right.
Okay, now look at the first question. What is the range of f? Well, ideally, if we can calculate this point, everything from there to infinity will be the range. Range is essentially y value. So, in order for us to figure that one out, x value is 0 here. Isn't that correct? So, f of 0 is how much? It's going to be 9. So, this point is 0, 9. So, the range is f greater than 9. Can it be equal to 9 or is it greater than 9? It has to be.
Because x is not equal to 0.
Exactly. It has to be greater than 9. Look at the next question. Next question says, explain why f has an inverse. Well, if you consider the black parabola, it is not one-to-one parabola. However, if you consider the green one, it is a one-to-one parabola. Sorry, one-to-one function. It's not parabola, one-to-one function. So, one-to-one functions are always invertible. Has an inverse.
Yeah.
Okay. Let's go to the next question. Find f inverse. Look at what we have originally, Amrita. Originally, it says y is equal to 2x plus 3 whole square. In order for us to get f inverse, so you interchange the variables. That is, x is equal to 2y plus 3 whole square. And now rearrange it such a way that only y will be isolated. And that, if you convert it as a function, that will be the inverse of f. So let's try to simplify this. Let me have some space here. Okay, so let's do this. Root of x is equal to 2y plus 3, right?
Right. Yeah.
Now from that you have y is equal to root of x minus 3 divided by 2.
Yeah.
Now remember, one may wonder, why are we only considering the positive root? Well, because we have seen function is defined only for x greater than 0. Only the green portion is defined, where both x and y are positive. Okay, so this is the inverse. So f inverse x is root of x minus 3 divided by 2. Clear?
Yeah. Clear.
Okay, now let's continue to the next question, Amrita. State the domain of f inverse. Now, this is something you would want to remember. Domain of an f inverse is same as range of f.
Yeah.
Isn't that correct? So now let us look at the range of f. We have already calculated range of f is
9. Yeah.
exactly. So here we say
X
x
is
greater than 9. That is the answer.
Yeah.
Okay, now let's look at the next question. Murtha. Given that g, our new function, is defined as ln x plus 4, find the exact solution of f of g of x. Okay, Murtha, let's break it down. But let me have some space. What is f of x? f of x is given to be 2x plus 3 whole squared, right?
Yeah.
We have seen it from the beginning. Now, f of g of x, what would that be? It's going to be 2. Now, substitute the g function instead of that x. What is g function?
ln x plus 4.
Ln x plus 4
Yeah.
plus 3 whole squared. Isn't that correct?
Yeah.
Now, let us not simplify this. The interesting thing is, it is given this is equal to 49, Amrita.
Okay.
So 49 is equal to this whole thing, 2 ln x plus 4 plus 3 whole squared. Now the cool thing is, you can actually take square root on both sides, right, Amrita?
Yeah.
So it is going to be 7 is equal to 2 ln x plus 4 plus 3, right?
Right.
Subtract both sides, blah blah blah. Let's do all of the steps in our mind. So 2 and 2 will get cancelled out. So finally, let's do that properly, Amrita. Sorry, maybe I shouldn't be doing it in a haste. So this is going to give us a 4, right? This 4 and this 2 will get cancelled out. It's going to be a 2.
I think 2 will be the other side.
Sorry, my fault, Amrita. This 2 will be here.
Yeah.
So what we have is something like this. Ln x plus 4 is equal to 2. Then we take e on both sides. E to the power this left side is e to the power the right side. So x plus 4 is e to the power 2. Right? And from that we get x is equal to e to the power 2 minus 4. And that is the answer to the question.
Okay. Yeah.
I hope it's clear, right? So we will continue the remaining later, Amrita. Thank you so much.
Thank you so much. Yeah.